All right, with just a couple more definitions, we'll be able to finally nail down what PAC learning is. So let's consider a concept class C. That is to say the set from which the concept that we're trying to learn comes from. L is our learner. H is the hypothesis space, so it's the set of mappings that the learner is going to consider. N is going to be the size of that space, so kind of the space of the hypotheses that are being considered. D is that distribution of inputs like we looked at before. Then we've got Greek letters epsilon and delta, where epsilon is our error goal, which is to say we would like the error in the hypothesis that we produce to be no bigger than epsilon. It could be smaller, that would be great. It would be 0, that would be awesome, but it can't be bigger than epsilon. But we could get really unlucky and actually not meet our error goal, and so delta is what allows us to set a kind of uncertainty goal or certainty goal, which is to say that with probability 1 minus delta, the algorithm has to work.
And by work, you mean has to be able to produce a true error less than or equal to epsilon.
Exactly.
So why can't we always force epsilon to be 0 and delta to be 0?
Right, so to be absolutely sure that we get 0 error. So part of it is because we are sampling training examples from this distribution D, and so it's always possible that we, for example, as long as there's probability mass on more than one example, there's always a probability that we draw a finite sample that only ever gives us one example over and over and over again.
That's fair.
So we just have to be really careful about that. And so if we're that unlucky, it's very unlikely to happen. But when that happens, our error is going to be very high. But that's okay because it won't happen very often.
Okay, sure. So basically, you can't force it to be 0 under all circumstances, either epsilon or delta. You can't force them to be 0 under all circumstances. So you have to allow some wiggle room there.
Yeah, exactly. It gives us exactly the wiggle room we need. And that's actually where this name PAC comes from. It stands for probably, approximately, correct.
Oh, I see.
So we'd like to be correct, but then we're just going to keep adding weasel words until we can actually achieve it. It's like, well, we would like to be correct, but we can't be exactly correct, so let's just be approximately correct. But we can't be approximately correct all the time, so let's only probably be approximately correct.
So using your words here, you could have called that 1 minus delta epsilon correct.
Yes, right. That's exactly right. That's what the Greek letters are playing, and correct is this error sub d of h equals 0.
Yeah, so 1 minus delta epsilon error sub d of h equals 0 doesn't roll off the tongue quite as well as probably approximately correct.
I would agree with that.
Okay, fair enough.